Hello. I would like to calculate the length of a circle using polar coordinates. Polar coordinates are another way to express the position of points in plane. If I have a point P like this, I can use the distance of the point from the point to the origin O and the angle that the segment OP does with the axis OX. So it's something like this, and there is a relationship. So this is Y and this is X, and there is a relationship between a pair XY, XY, and the pair theta rho theta. I will put its theta rho. Okay. Then I have something like sinus of theta. It is equal with Y divided by rho. Then I have Y. It is equal with rho sinus of theta, and then I have cosinus of theta. It is equal with X over rho, and then X, it is equal with rho cosinus of theta. If I know Y and X, then I can calculate rho and theta in the following way. Rho, it is equal with square root of X squared plus Y squared, and theta is equal with arc tangent, it's arc tangent of Y over X. How can we use polar coordinates to calculate the length of the circle? If I have a circle like this, if I have a circle like this, then I will do this. This is constant, and rho for a circle is first of all the equation of the circle in Cartesian coordinates of a circle centered in the origin is x squared plus y squared. It is equal with r squared, and that's it. The equation of the circle using polar coordinates will be rho, it is equal with r, because this is what the circle is, the set of points which are found at equal distance from center, and theta, it is part of 0 to pi. And we see already that in the case of polar coordinates, rho and theta are independent. Let's go back to our drawing, and I have in here d theta, and in here I have ds, which is the infinitesimal arc length, and in here I have a theta, and this one is r. Okay, the length of the circle is like this. It's integral from ds. And the measure of an angle is d theta, of an angle, and in our case we take into account d theta is the length of the arc, which is between the segments of the angle, divided by the radius, and in our case the radius is r. This means that ds it is equal with r d theta, and theta is between 0 and 2 pi. Then I have integral from 0 to 2 pi from r d theta, which is equal with r integral from 0 to 2 pi from d theta, which is equal with r theta from 0 to 2 pi, which is equal with r 2 pi minus 0, which is equal with 2 pi r. So the length of the circle is 2 pi r. Of course, this is no big deal, and everybody knows which is the length of the circle. The most important thing is that the calculation using polar coordinates, it was extremely short and easy. And this is the most important thing. And by using polar coordinates, we calculated the length of a function. And doing calculations in Cartesian coordinates for lengths of functions, it is extremely difficult. And in some cases, not all, of course, changing the coordinate system helps and makes the integral much simpler. Like we see in here, it's a very simple integral to calculate the length of the circle. Thank you for listening.